Hey everyone, it's Sean. Welcome back to the channel. What I have in front of me is a SounDigital 800.4 S Evo 10 coming to me via customer because one of the outputs channels is as soon as it's hooked up, it amp goes into safe mode. So just troubleshooting. You can see if I zoom in, you can see that these MOSFETs was coupled to what is this? An IR S2092 S IRS 2092S. That's going to be the basically the digital audio amplifier. This being a Class D amplifier. Output channel MOSFETs for Class D amplification. When I turn this on, actually one of the things I found right off the bat was a little piece of solder or some kind of metal thing. You see how tiny that is. Pretty close to this diode over here. Okay. And this resistor actually situated between them. It might have shorted them out. I'm going to have power off for now. Let me just double check. Yeah, no, looks to be no power. And just going to check across this diode. Okay. I'll put my multimeter in diode check here, and here's a known good. Okay, so 1.6 that way. Voltage drop, so this will probably read more like a diode that way, and it does. So let me check this one. Yeah, so we are there. What's it reading the other way? So we're seeing some issues here. The other way, whether that is an issue with the diode itself, I'm kind of doubting it right now, but probably something to do with this IC or all this corrosion I see in here. And let me actually shine a light on that for you. Get my microscope on so you can see that. But while I'm working on that and it's getting on, let me just go ahead and come across these caps sitting here. So they might be it's 4 microfarad. I should be able to read it with a capacitance check, but with it situated on the board, it's always a possibility I won't. So there we go, 3.7 microfarad. So it looks like these caps might be good. Here goes another 4 microfarad right below it. It's showing 6. So again, keep in mind it's in circuit. This one's close to 6. Let me check this right behind it. So we're getting 15 microfarad. That's 4. So close to 15. So most likely not an issue here. Let's see, what am I getting across this? Let's see, 10 plus 3 zeros, so a 10K resistor. Yeah, that's reading as a 10K resistor. So it's possible that this diode is bad. Have to figure out what kind of diode is there. Just want to go across each pin to see if there's anything direct connectivity to any of these pins over here. Yeah, so 2 ohms going to this 4th pin down, and 2 ohms going to there. So that might be having an effect on it. This driver IC. It's always possible, but when we turn it on, actually let me show you that corrosion first and get a light on this. And let's bring up the microscope. Okay. There we go. Oh, bottom. Yeah, there, right there. A lot of corrosion at the output of this MOSFET here as well. Looks like some water or something got across here. Not seeing significant damage. It's obviously something I can clean away. We will need to check the pins and stuff. Now the caps and that resistor there do read fine. It's very possible that the output MOSFETs are bad. So if I was to go across a resistor, actually, let me just go across a resistor right now. I believe that's like a 1 ohm resistor. Lead keeps sliding off there. So actually, the resistor is not looking too good. Okay, and that could be because it's in circuit with a bad output channel MOSFET. Should be seeing something like that, 1 ohm. Okay, so that is a 1 ohm resistor. I'll probably end up getting it put on order. Let's check the capacitor sitting here. It's a 1 microfarad cap. There's again a lot of corrosion. I might not get a reading with it in circuit. Showing 2000 microfarad. Let me check with the upper one. Let's look at a clean one. Okay. Yeah, so that's reading, approximately the same in circuit. Let's go ahead and check this 100 nanofarad. That might be too small of a value for me to check with my multimeter. Saw 200 briefly. 280. Okay. So again, in circuit, let me check with the corroded one. Yeah, nothing there. So let me go back to a diode check, and I kind of just want to, let's see, positive, negative to center. So we're getting a diode there. And open there. Let me put the negative probe around this way. Diode 5. So that's currently kind of testing good. Okay. Is that going to be the same with this one? Yeah, 0.5. Oh, no, that's complete different. Go back up. No, that's the same. Okay. Let me check this bottom one. That's 0.5. And with a known good, 0.5. 1.3. 1.3. 0.5. All right. Let's compare the one above it. 1.5. 0.5. 1.5. 0.5. All right, so I would assume maybe this resistor needs to be replaced. These are looking okay, but I might replace them anyways, just in case. This IC could also be bad. We can get this replaced. I don't think we're have any issue with this. Let's see, this tantalum cap sitting there. 72 one way. What's it measuring this way though? Again, 100 microfarad. Is that going to be the same up here on this other one? Yeah. And what about the other way around? Yeah, I'm getting very similar values with the next one up. So thing is that now I'm gonna put my positive lead to ground and just kind of do a once over on all the pins here. Pin 1. Oh, let me put this to diode check. 1.4. Now instead of me moving this 1.5 a lot, you can see it's charging. There's a cap line. I'm just going to go to the one above it, and you're going to have to shake your head and say, I believe I'm testing the same thing. All right, next pin, 1.9, 1.9, 1.5, 1.5. All right, so 1, 2, 3. Let's go to pin 4, 1.2, 1.2, 5, 1.8, 1, 2, 3, 4, 5, 1.7, almost 1.8. Let's see. Start at the bottom, pin 1. Here, first pin down at the bottom. And actually, this is probably pin 1 because there is a dot down there. So 1, 1.1, 1.0 on a good. 0.6 on pin 2. 0.6 pin 2. 1.2 pin 3. 1.2 basically pin 3. I think I already checked this one. 1.8. 1.8. All right. I'm going to come around to the other side and test. Probably just be easier for me to situate it up like this. Okay. Again. So how many pins is this? 1, 2, 3, 4, 5, 6, 7, 8. So it's a 16 pin IC. So this is probably pin 9. 1.2. Another pin 9 up there. And it's counting. There's a capacitor it's charging somewhere in circuit. Same thing here. Compared to another one. 1.7. 1.7. 1. 1. 2. 1.2. 3 left. 1.4. 1.4. What are we getting on this one? My last two. 1.3. 1.3. And then pin 18 here. 16, whatever. 1.4. 1.4. So at least with a diode check, this is not an operational check, but with that, everything to and from each pin seems to be okay. So this diode actually might just be bad. Question is will I be able to find a substitute for it? It does have some markings on it. It says T4. P4. But power it on. All right, we're definitely drawing almost, let's see, got let me turn it on. Drawing 1.6 amps. Okay, when this gets turned on, we'll go ahead and turn this off and move it out of the way. There we go. Got it on. And yeah, here's some of your differences. Okay, so get 30 volts here on that pin, similar to a known good. Then on this second MOSFET up, negative 30 on that pin. Same here. This one I'm seeing a full negative 30. Up there I'm seeing negative 24. So think issue here with this diode, 4.9 on this side, 4.9 on this side. Over here I'm getting 0.7, 0.5 on that side. There goes 0.7 out of the IC. There goes 0.5 out of the IC. So it's possible that that's blown. Could be possible the diode's bad there, but I'm thinking more of an internal issue on this IC. They'll both have to get removed. And we got quite a bit of corrosion at the MOSFET here, so that could explain why we're getting high current draw, because this is going to drive that IC, and it looks like we have an issue in this portion of my circuit over here. So I'm going to get some parts on order, take some things out, test it, and we'll go from there. Well, I've broken the board down a little bit more. Yeah, this IC right here is removed. Got a replacement. IRS 209 to STRPBF. There you go. There's the part. All right, so I'm just gonna, I think I'll start off first by replacing this IC and testing, and then if we get this channel of audio back, then no sense in redoing all this over here. We'll just see how it goes. All right, got the IC replaced. Let's see what we got here. 9 0 0 0. It seems like might need to replace these guys too. They were scrubbed off. My assumption, although I don't know for a fact the part number, I believe they're STD Sierra Tango Delta 40NF10s. I believe that's what type of MOSFET they are. So I'm going to get the replaced with these and see if that makes a difference at all. Well, I've got the MOSFETs changed out, and let's see, any difference. Okay, oh, let me go to DC, compare them with the top one, 0.2, this one, 0.5, so that's still elevated. Let's go to this leg, negative 23, this leg, negative 29, that's still elevated. This leg, negative 29, negative 29. So this is effectively cut off this this MOSFET. See the back side, 30, 31, 31. That seems to be okay. Yeah, that's elevated. 5.5. So yeah, I've still got issues even with this replacing that. I've got other parts ordered, but I checked these components and removed and tested, and a lot of them seem to be okay. I think I need to start looking more at the PCB. So I'm going to explore a bit, come back, let you know what I find out. Oh, exploring a little more, I have done, and you can see, I think water got up on here. I removed the paint and polished up the copper pads you see here. But we definitely have discontinuity in some places. You see all these little dots. This is actually, these go through this PCB and they touch a component on the other side. So this is a 2-layer board, the bottom side carrying some voltages, bringing it to the top side to some surface mounted devices, etc. There are 2 spots that are really bothering me from what I've seen so far. Well, if you look at this one right here, let me zoom in a bit. So you see this point right here, it looks tarnished. That's one of those through hole things. If I was to follow the lead down, it touches here. We actually don't lose continuity through the board on that one. But you can see I've cleared out an area here. There's one of those through hole pins here. So there's one to the left of it. But this pin does not have continuity with its trace, this eyelet. And then we've got another eyelet over here that does not have continuity with its trace either. Everything else that I've tested so far seems to be good. So what I'm going to do is I'm going to come through this backside. I've kind of cleaned it up a little bit. I'm going to repair these 2 traces and touch up all the solder and power it up again and see if we can get it to work. Now that all that's done, I got to put conformal coating and stuff on it all when I finish it up, but we're good enough to test. Let's power it up. All right, no boom boom yet. That's good. Why don't we check some voltages? Come from my negative lead here. Let's see, do we have any difference now? 0 on there. 0 on there. That looks to be a tad bit different. See what I got here. 6, 15, 16. Let's hear. 15, 16. Woohoo. Do we have a working channel again? 20 volts there. 20 volts there. Oh, we're looking good. Let's check this upper pin here. Not seeing anything on that upper pin. Nothing there. Center pin, same as going on backside. 20. 20. Then 4 there. 3, 4. Same thing there. We might have this channel working again. And I'm drawing 1.6 amps from the power supply. Actually closer to 2.5, 3 amps. Oh no, we need to turn that down. That is smoking. So there's something here it's not liking. Ooh. All right, so I've still got more work to do. We fixed the channel. I'm thinking maybe these caps need to be replaced or something. I did see some smoke coming off of it. Let me, cause 3 amps, that's way too high. That's way too high. I would imagine if I turned the amperage up, it wouldn't get that high. Let me do some more digging around, because that's got 3 amps and starting to see some fumes coming off. That doesn't sit well with me. All right, so this I've actually moved it up to here now. I'll explain why here in a second. But this Sierra Tango Delta 40 in November Foxtrot 10 MOSFET, even though the several factors concerning it are good, such as the drain source breakdown voltage, the gate source voltage, gate source threshold voltage. Those kinds of things are pretty good. What is not good with it is the RDS and the QG, or gate charge. And so I did quite a bit of poking around, swapping off components and stuff. Here, let me quit being pretty stupid and take my rings off. And, I was like, okay, so why are these getting really hot? Maybe there's an issue with my inductor, these output capacitors or something, typical things that would cause a current drain, maybe draw more current from the MOSFETs themselves. And no, absolutely none of that was it. So I ended up switching these MOSFETs down here and the one that I'd chosen up to here. And let's just take a look, see what happens when I turn it on. There we go. We got it on. Okay. And we can see 100% with my thermal camera right here that the MOSFETs sitting at the bottom, the ones I moved from here, are no longer getting hot. But the ones I have up here, they are drawing more heat in the circuit. As a matter of fact, as I increase, hold on a second. Messing with the wrong thing. Let me turn down the voltage. Okay. Let's get you above 12. There we go. Turn this back on. All right. Now, as I increase the current, you see that current is going up, and they are most definitely getting hotter the more I let them draw current from the power supply. So what is essentially happening, and I don't want them to get too hot, because they'll get too hot sitting on. They were getting hotter over here than they were up here. I was worried that there was something in the PCB that was creating that issue. But what essentially is happening, because the gate charge value is too high, because it's too high, essentially they're switching at a slow rate, so they're kind of maintaining both sides on a little bit too long. Is that the proper way of saying it? Not too sure, but they're basically in a constant conducting state instead of switching, and so that's drawing more current, and that is most likely the reason why these are getting too hot. So the lower the gate charge, the faster switching you get, the low gate drive loss. And then for like the RDS, it's typically represented in ohms, in this case milliohms. The lower your RDS value is, you reduce conduction loss, and then you have lower MOSFET heating under load, which is more suitable for higher output currents and better efficiency. So I suppose I just selected a MOSFET that was just not up to the task, and I need to be a little bit more cognizant of that later on, because if I'm going to make a recommendation of a suitable sub, I need to look beyond the actual voltages and current and actually make a recommendation based off of several other factors as well, including the QG and our RDS values. So essentially, that's the issue why these aren't working. So, I mean, as long as I can control the current, I've got output now at all four speaker terminals, which is great. I just have the wrong MOSFETs selected up. So what I'm going to do is I've chosen a new set of MOSFETs, some IRFR, what did I choose? Excuse me, not IRF. Sierra Tango Delta 25 November 10 Foxtrot 7 in channel MOSFETs in the DPAC 3 configuration, which have, I'm kind of looking over my PDF file on it, which have a, let's see, VDES of 100. We're looking at, let's see, what are some other things that we care about? We care about, drain source breakdown voltage is 100. The continuous drain current is 25 amps. The gain source voltage, VGS, is -20 to +20. So we've got plenty of overhead in those areas. The VGS gate source threshold voltage is 4.5, which is half a volt more than what you would have had with the IRF 6645, which is the original pairing that goes with our gate source driver over here. So you got a little more headroom there. The gate charge for the 25 November 10 F7 MOSFET that I'm going to put on order is 14 nanocoulomb. So that's within the range of more closer to like the IRF 6645, which it was originally purpose MOSFET to work well with this. And then it has a lower RDS of, what is our RDS? I want to say it's 35 milliohms. Yeah, RDS 35 milliohms. So that should be a good selection to work with this IC, this driver IC over here, the IRS 2092 Sierra. So I've got them on order. When they come in, we'll swap them out, and I think we'll be good enough to actually start running and testing this at that point. Well, here's the replacement MOSFETs I just got in. So I think we'll be okay using these. Part number Sierra Tango Delta 25 November 10 Foxtrot 7. I'm going to get these swapped in, removing the two that I had down here and moved up there, and get these two replaced. And we'll test again underneath thermal camera, keeping an eye on the current draw to see how they are performing. All right, so here we go. As far as what you see here that's hot, that's just this inductor right here from replacing those two in-channel MOSFETs. Okay, everything else on the board is pretty cooled down. You can see that I have my power supply set to 12 volts. I have another power supply over here that I've got set to another 12 volts. Well, actually 8 volts. And I'm about to trigger the REM. It is turning on. You can see that's drawing 1.5 amps sitting there. I'm looking at the PCB. Okay. And already I notice, if you can, let me zoom in here for a second. All right. So maybe you can see this. Those in-channel MOSFETs are not getting hot. Now, what is getting hot, I would suspect, would be these kind of like emitter resistors or whatever sitting here, acting as a voltage divider in the circuit. It's two resistors side by rolling after another. I believe they're probably voltage divider. They're probably not tied to the emitter. I could be wrong though. You also have a negative and a positive voltage regulator sitting over there. So anyhow, let's see if I increase the amount of current that can come from the power supply. Is it going to jump up to 2? No, actually, as I'm increasing it, it stops right there at 1.7. And so now we have an even better indicator that we're not drawing excessive current anymore either. And yeah, the MOSFETs are not heating up. Not heating up You can see the tip right there, and right there on the camera, ignoring these thermal imager, ignoring these resistors here. They're staying very, very, very cool, relatively. So yeah, that's exactly what I want to see. The circuit is a lot happier now, and so I think we're good enough to test with an Oscope. So that is what I'll do next. I'll see, when do we start. Yeah, let it get right about there. Okay, yeah, let me set up my Oscope, and I'll test from there. All right, so I am generating an 80 hertz tone at 0.5 volts peak to peak, or 500 millivolts peak to peak. At the input of channel 1, I've kind of just gave a rough estimate, amplitude, and here on my crossover adjustments, I can see I get 56 volts peak to peak out at 80 hertz. Okay, so the crossover and the amplitude control for this amplifier, the 800.4D, you have 2 pairs of each. The first pair controls channel 1 and channel 2. The second pair of those controls channel 3 and channel 4. So if I switch over to channel 2, I should see roughly the same thing. What was that before I forget? Was that 56, roughly 56 volts? Yeah. So let me switch this input over to channel 2. Now, I'm always monitoring the power supply up here in the corner as well, just in case something wonky happens when I add audio into the circuit. Keep an eye on how much current's being drawn. Okay, so we're now on channel 2. There we go. Seeing 73 on there, so you can see there's a slight disparity in that circuit. You know, it could be the MOSFETs or have gotten weaker over on that side, but it is still working. You might be wondering why it's kind of fuzzy. It's because I'm not using the ground probe on here either. But yeah, we've got a sine wave, so that is good there. All right, let me switch over to channel 3. Channel 3 is where we have the new MOSFETs that I chose for the circuit to replace the ones that had been scrubbed out. Again, I'm keeping my eye on the power supply up there. Channel 3. And what am I getting on channel 3 over here? All right, so I can see 21. Let me change this crossover a bit. Yeah. And 57. Amplitude I can control. I'm starting to distort the signal. I'll come back a little bit. So 57 on channel 3. And let me go over to channel 4. I wonder if channel 4 would jump up and be around 70, something like the other side did. That's a nice, pretty signal there, at least on 1 and 3. And no, channel 3 and 4 roughly about the same. So yeah, we just got slightly more amplification than what we need on channel 2. This is going to be repaired for now. I'm going to go and UV mask everything here on the bottom, put it back together, and give it back to the customer, and just let them know where it sits, because they're not looking to break the bank. But we have all 4 channels. So in the event the MOSFETs do go bad here on channel 2, well, now I know exactly what to get right there. Okay. Which makes me wonder if the other SounDigital amp that I've got on my bench that I'm struggling with right now, if maybe the stamped MOSFETs on it, what were they marked with, like something like I don't even remember, 44 or something. Maybe that was to, you know, wrong. Maybe they were like a subset that had a lower QG gate charge on them. I think I might play with that device a little bit more and go back and look at it. Anyways, I'm rambling. Let me get this taken apart, get some UV mask on it, get it cleaned up and back together. That's going to include new heatsink compound where the heatsink compound needs to go. So there we have it. 800.4S Evo put back together. I cleaned it up as best as possible. Do I think that the in-channel MOSFETs that I originally replaced and that one IC were the issue? Kind of no. In hindsight, after going over everything, I believe the issue were those traces that were destroyed, but you know, being a part of that circuit, they were replaced anyways, and so, and we at least now know in totality, all of us here, what in-channel MOSFETs to use in that circuit in order to get it to operate correctly. Albeit the old ones were obfuscated a little bit there. But that's going to do it for this repair. I've pulled back out the other one, as you can see, and I'm about to try doing different MOSFETs on it, see if I can get it back working. But if you enjoyed this video, let me know. Give this video a like, leave me a comment. If you're new to this channel, consider subscribing. You're already here, why not? I mean, I've got more returning viewers who are not subscribed than subscribed, and if y'all would just subscribe, the channel would actually grow beyond the 2K that I have. Subs are really important for that algorithm. Or maybe you just find me a little bit too boring because I'm not as charismatic as some of the other YouTube channel makers. And that's fine. You know, everybody has their own style and preference they enjoy watching. Either way, thank you for those of you who have attended to this channel and watched. I won't eat up too much more of your time. Take care and goodbye. Bart?